Okay, let's continue with mortality, and we're going to look at direct age adjustments. And the data set and the table I'm going to use comes from a lecture by Marie Diener-West and Sukan Kanchan-Araksa, both PhDs at Johns Hopkins University. And if you want to get this slide set yourself, it's right here. Go for it. So this here table is looking at single males and comparing them to married males, and we're looking at the death rates for these two groups, and there are age-specific rates that were listed here, and you can see the age groups here: the young 15 to 24-year-olds, 25 to 44, 44 to 64, 65 to 74, and the 75 and older. So who do you think is more likely to die, the single males or the married males? Well, let's look at the crude mortality rates here. And so down here we see 8.09 for the single males and 17.26 for the married males. So the married males have a higher mortality rate. So the lesson here is don't get married, guys. But wait, it's not quite that easy. Let's look specifically now at the age-specific rates for each one of these. And I'm going to circle the ones that are higher. So for the young ones, 15 to 24, we got 2.24 deaths per 1,000 for the single males and 2.14 deaths per 1,000 for the married males. So single ones are higher. Okay, what about the next group, 25 to 44? Their death rate is 4.89 for the single guys and 2.61 per 1,000 people for the married ones. So the death rate is higher for the single males. All right, what about the next one, 45 to 64? 30.68 deaths per 1,000 if you're single, and 15.84 if you are married. So this is not even close. Look at this. It's almost double. And next one, we got our 65 to 74-year-olds, and it's 92.52 deaths per 1,000 for the single men, and 50.15 for the married men. Again, that's quite a difference there. And finally, let's look at the last one. So the 75 and older bachelors, their death rate's pretty high. It's 323.55 deaths per 1,000 compared to 118.03 deaths per 1,000 for the married guys that are older. So look at that. The age-specific death rates for every single category here, every single age range, is higher for the single males than the married males. Yet how is it that the married males had a higher crude mortality than the bachelors? How does that make sense? Well, it all has to do with the populations. And if you look at this, let's look at how many people are in each one of these groups in the bachelors and the married guys. So for the young ones, there's 17,724,000. Remember, this is in thousands. So about 17 million here. And here we only have about 3.4 million people that are married. So we got a lot more younger guys. What about this next group, 25 to 44? 5 million in this group and 23 million in this group. So we got more over here. A little bit as we get older, 1 million, 18 million. This group, 364,000, 5 million. And the 75-year-olds and over, 199,000 versus 2,331,000. So what are we noticing here? The young guys make up the bulk of the population when they're single. But then for all the married people, as we get older, most of them are married, and by quite a long shot. So for the single people, you got a lot more young, healthy guys. And then for the married people, we got way, way, way more older people. And older people tend to die more often than do younger people. So if you have a population of mostly young people, and you have a population of more old people, which one's going to have more deaths in it? Of course, it's going to be this one. And because there are so many more of these older people, what ends up happening is it skews the rate because we have more people actually who are dying. Look, we had number of deaths here, we had 905,000 versus number of deaths of the single, we only had 201,000. But that's because we had so many more old people in this group. This group was mostly young people over here, and so this skews the numbers. But we can fix this. We can do an adjustment that will take all of this into account. And so we're going to do a direct age adjustment, and I'll show you how to do that. And so step one is to create a standard population. So remember, we're comparing two different populations here. So it's comparing apples to oranges. So we need to create a standard population. Now, the one that used to be used a lot was the census date of 1940. But then as time went on, we've thought that that really didn't reflect our demographics, because in 1940 there probably weren't very many 80-year-olds or 90-year-olds, and we have those now. So now we use the population from the year 2000. But it really doesn't matter what population you use. You should just use one standard population for both of them. So for our standard population in this example, let's just add these two populations together. So what we're going to do is add this number to this number. We'll add this number to this number, this number to this number, etc., until we get a conglomerate of these things. So let me just add them all up for you right now. So here you go. Here are all the numbers for the standard population. And so that's step one. And so now let's look at the rest of the numbers actually in this table. So 39,745 of these young people died out of a total of 17,724,000. And if you divide this by this, and then we multiply it by 1,000 so we can get death rate per 1,000, then we're going to get this number here. So similarly, if we divide 26,372 by 5,390,000 multiplied by 1,000, we're going to get this, 4.89. And so that's how each one of these death rates were calculated. And that's important because we're going to need these death rates for the next step, and the next step is to apply the rates to the standard population. And what you'll get from this is a new number of deaths. So what we're in essence saying is, if instead of there being 17 million 15 to 24-year-olds, there were 21 million 15 to 24-year-olds, and they still died at this rate, how many deaths would we have? So let's do an example for this. So this is 2.24 deaths per 1,000. So that's the rate, and let's apply it to the standard population, which is 21,151,000 people. And so now, how many deaths would we get? We would get 47,000 deaths. So here are the numbers now of the number of deaths if you applied it to the standard population instead of the actual population we saw. So we can get all this, and we can add all these deaths up. I'm going to put it over here. So if we applied the same death rates instead of to this population to our standard population, instead of getting 201,000 deaths, we would get nearly, get over 2 million deaths. So don't try to compare these because they're completely different. This is a different population and this is a different population. Now let's do the same thing over here with the married males. We're going to do the exact same thing. We're going to take this rate and multiply it by the standard population. And so that's what I've done here. So now if you were to use the standard population instead of the actual population, instead of seeing 7,000 deaths with this rate, you would see 45,263 deaths. And so we got all these numbers here, and we can add those up just as well. So adding all these numbers of deaths up, we get to 1 million. Again, don't try and compare it to this, because this population and this population are not the same. Now, that's the exact point, though. Now we've got this one and this one both coming from this population here, from our standard population. So now we can compare these two numbers because we are comparing apples to apples. And now you see that for the single males, we had 2 million total deaths coming from our standard population. And from our standard population of married males, we only had 1 million. So the death rate is different. So let's actually divide this by this. That's our step 3. And so then let's calculate them. So 2 million something over 77,316,000, we would get 27.68 deaths per 1,000 in this year, and then doing the same thing here, taking 1 million something and dividing it by 77,316,000, we would get a new age-adjusted death rate per 1,000 of 13.17. And now you can see, comparing apples to apples, that the single men, they die at a greater rate than do the married men. So I guess it is good to be married then. So, and another point I just want to make, which we had said a couple of times throughout, is that these are not real rates. These things here, 27.68, 13.17, because they're really from a made-up population, this standard population that we made. And we arbitrarily said, let's just add these two populations together. We could have used the population from 1940, or we could have used the demographics from the population from the year 2000, and we would have come up with different numbers. But what this is good for, it's good for comparing two death rates in two populations that may not match for some reason. And so this is how we do a direct age adjustment. Watch this video a couple times if you need to. And it may help for you to go through these calculations on your own. If that helps, then do it. And as always, if you have any questions, please feel free to email me or put a comment in the comment section. All right. Talk to you later. Next, we're going to do indirect age adjustments.